Assalamualaikum warahmatullahi wabarakatuh. Today I will be presenting to you a short presentation on the introduction of advanced statistical analysis. This is for the code of DNE922. So this presentation will be the last of a series of presentation that I've made for this code. Please be advised that almost all of the materials that you can find in this presentation are available publicly on the internet. Okay, I'm just here to introduce you to some of the more advanced techniques that are available at your disposal if you choose to utilize them in your analysis. So the first one would be on factor analysis. Okay, so the topic here, a layman's general introduction to factor analysis, which is absolutely right. This is just an introduction. If you'd like to know more, you can come and we can have discussion, or you can look more deep into it, okay, by searching the keyword factor analysis. So factor analysis, FA, basically it's a process of a data reduction technique. It's a technique to reduce the data designed to represent a wide range of attributes on a smaller number of dimensions. So by definition, it is a statistical approach that can be used to analyze interrelationship among a large number of variables and explain these variables in terms of their common underlying dimension, or what is known as factor. So in your analysis, if you have a tremendous amount of variables that are involved, and sometimes we can find this a little bit overwhelming, so we can group them, okay, into what is known as these factors, and make the variables more manageable. So what is FA? Factor analysis is a general name denoting a class of procedures primarily used for data reduction and summarization. Variables are not classified as either dependent or independent. Instead, the whole set of interdependent relationships among variables is examined in order to define a set of common dimension called factors. So these variables with common factors, they will be grouped in one order. Okay. So other variables with other factors. Okay, so take many variables and explain them with few factors or components. So basically, this factor analysis groups these variables into factors and components and making them more manageable. Correlated variables are grouped together and separated from other variables with low or no correlation. So we have triple component analysis and factor analysis. So while often used similarly, PCA and FA are distinct from one another, where the principal component analysis, it extracts all the factors underlying a set of variables, Okay, so and then the number of factors equals the number of variables. So this PCA completely explains the variance in each variable, whereas the factor analysis analyzes only the shared variance. So, so error is estimated apart from shared variance. So in terms of the conceptuality, FA produce factors, PCA produce components. Okay. So factors cause variables, components are aggregates of the variables. So if you're looking for factors, then you might want to go for factor analysis. If you are more interested in the components, then you go for PCA. So the underlying causal model is fundamentally distinct between these two. Okay, so you can see the difference between the factor analysis and the principal component analysis. So the purpose of factor analysis is to identify the underlying dimensions called factors that explain the correlations among set of variables. So we have a set of variable with common dimension. So how do we know they have this common dimension? We will know when the um, process of calculating this factor analysis has been completed. Okay, so the factor analysis will group these variables with almost equal dimensions into one factor or one group. So to identify a new smaller set of uncorrelated variables to replace the original set of correlated variables for subsequent analysis, such as regression or discriminant analysis. So we can use FA as a preparatory measure to prepare our variables, to group them into factors before we conduct other type of analysis. The types of FA, exploratory FA, summarizing data by grouping correlated variables. It investigates sets of measured variables related to the theoretical construct. So this is where your theoretical construct is important. So usually done near the onset of research. The type of FA and PCA we are talking about. So the second type is the confirmatory factor analysis. So this is more advanced. When the factor structure is known or at least theorized. So testing generalization of factor structure to new data. This is tested through SAM methods discussed in the next chapter. Okay. So this is a preparatory step before we move on to the SAM or structure equation modeling. So the assumptions here, models are usually based on linear relationship, how one group of variable affects the other. Models assume that the data collected are interval scale. Okay, so please remember in terms of the level of measurement. Multicollinearity in the data is desirable because the objective is to identify interrelated set of variables. So the variable must be correlated with each other. Okay, and the data should be amendable for factor analysis. It should not be such that a variable is only correlated with itself and no correlation exists with any other variable. So the correlation between different types of a variable is important. So in terms of sample size, minimum numbers of variable for factor analysis is 5 cases per variable. Ideally, the number of observations are greater than 20 cases per variable. So the general steps, step 1, selecting and measuring a set of variables in a given domain. Next, data screening in order to prepare the correlation matrix. Step 3, this is where the calculation starts. The factor extraction process. Step 4, factor rotation. Which type of factor rotation that you are going to choose. Step 5, when you get the factors, where the variables has been grouped into factors, this is where you need to interpret. Okay. And then further steps, validation and reliability of measures. Okay, so how do you know you have a good factor? Meaning that a good grouping of variables. Okay, a good factor makes sense. So how do you know that this group of variables makes sense? So that is from your theoretical construct. Okay, it will be easy to interpret, meaning that those variables that comes into one group, it is understandable why they are in that particular group, and other variable which are in another group, so you can easily identify why they are in that particular group. Okay? So this is where your knowledge about the subject matter is important. It has a simple structure in terms of the correlation with each other, and it lacks complex loading. So problems with factor analysis, unlike many of the analysis so far, there are no statistical criterion to compare the linear combination too. So yeah, uh, it depends on the interpretation of the researcher. Okay, so it is more art than actual science, and it's a lifesaver basically. Okay. Well, there are some critics on this method of factor analysis, but if you do the factor analysis based on very strong theoretical construct with good literature, it is generally can be accepted. Okay, so that is on factor analysis. Next, we move on. Okay, next we move on to Next we move on to structure equation modeling. Okay, so structure equation modeling, Sam, a general overview for human beings. Okay, so this is just to introduce you to structure equation modeling, uh, so that you may initially decide whether this technique is suitable or not for your research. Okay. Well, uh, let's go on. What is structure equation modeling, known as SAM? It's a very general, very powerful multivariate technique. So it's basically a multivariate technique. So if you can remember previous videos that I've included, okay, we have univariate, bivariate, and multivariate. So basically, the SAM is a multivariate technique. It is a bit specialized, specialized version of other analysis methods. So major application of SAM when you can use it, causal modeling or path analysis, or when you're doing the CFA, confirmatory factor analysis, second order factor analysis, covariance structure model, and correlation structure model. So what are its advantages? We are able to test model with multiple dependent variables. So all these dependent variables that we got from literature and whatnot, we are able to test them basically at the same time. So we do not need to test them one by one. Okay. And then ability to model mediating variables. So this is when the construct can become a model. And then ability to model error terms, we can define the error. Test the coefficient across multiple between subjects group. Okay, so we can, if your model has different interrelated groups, we can test them uh, individually, okay, separate them. Ability to handle difficult data, longitudinal with autocorrelated error, multi-level data, non-normal data, and incomplete data. So SAM allows distinction between observed and latent variables. Okay, the IV, DV. Okay, so basic statistic in SAM is the covariance. So it's not just for non-experimental data, viewed as standard statistical procedures, okay, as special cases of SAM. Statistical significance less important than for more standardized techniques. Okay, so this is SAM with path diagram. This is the basic structure of SAM. Okay, so as you can see, we have all these types of shapes in this model. So the oval one are the latent variables or the factors or the construct. Okay, so over here, squared are observed variables, measures, indicators, and manifest variables. So the IV and the DV. So between the oval and the square. Uh, the single pointed arrow is the direction of influence relationship from one variable to another. So how does the latent variables influences the observed variables? How do we manipulate this? Okay, it's called intelligence here. And how does it affect? Okay, you can see the arrow, the square here. Okay, what is known as the observed variables. Okay, so how this affect, how intelligent affects test 1, affects test 2, affects test 3, test 4, and test 5. Um, the double arrow line is an association not explained within the model, meaning that between test 1 and test 2, there are some association and it's not being explained here. So this is another example of a structure equation modeling. Okay. So this is how family support affects, okay, depression affects physical health, affects kids rating, affects spousal rating, and affects self-related closeness. And over here, we can go into detail where how the depression level affects depression number 1, number 2, and number 3. How physical health also affects the self-rating, MD rating, and number of visits to MD or the doctor lah. Okay. So this is a structure equation modeling. So we have the IV, we have the DV. Depends on which way you're looking at it. Okay. So it can explain everything in the model in one go. Yeah. So you do not need to separate between like doing analysis between family support and depression first, and then you have to do another analysis, family support and physical health. Okay. So basically you can do everything in one go. Okay. So here there is the relationship between depression and physical health is not explained in this model. So what can you do with this model? Latent and observe variable. We can just if you want to observe between dependent and dependent variables, how it affects independent affects the dependent. Yeah, you can do that with this model. Multiple indicators of the same concept, a remeasurement of the errors, restriction on model parameters, and best of all, the test of model fit. So what can't you do is to prove causation. Okay, this is basically an this is basically an over summarizing of the model, and we can also prove a model is so-called correct. Okay. Next is confirmatory factor analysis. Is more related to latent variables, has certain measurement error, no causal relationship between latent variables. Okay. So latent variable of interest to the researcher, not directly measured. The common variables, inflation, trust, democracy. These are some of the types of variables. Terms, nomenclature, symbol, and vocab. A measurement model. So what is a measurement model? This is part of SAM model dealing with latent variable and its indicators. And structure models, okay, it's different. Set of exogenous and endogenous variables in the model with arrows and disturbance term or the errors. The general model includes latent variable model. So this will show the relationship between the latent variables. The measurement model, observation between latent variables and observed variables. So normally when we do structure equation modeling at our level, we are just interested to see the relationship between latent variable and observed variable. So we are more interested in the measurement model. Okay, so another sample of structure equation model. Okay, so those are some of the things that are not explained. 6 steps to modeling. You have specification, implied covariant matrix, identification, estimation, model fit, and re-specification. So in the first step, specification, theorize your model. What are the observed variables? How many? So this is usually comes from your literature review. What are the latent variables? So also comes from literature review. What are the relationship between between the latent variables themselves. And what are the relationship between latent variables and observed variables? So how latent variable affects the observed variables. So these kind of things can only come from your reading. Okay. And then correlated errors of measurement has to be determined. Next, identification. Rules of identification by type of model: classic, econometric. Either you use recursive rule, CFA, three indicator rule, general model or two-step rule. This can be quite technical, so if you're interested to study more on this, I can suggest a few literatures that can help you to further get into structure equation modeling. Okay. Next is the model fit. We have component fit. Use substantive experience. Are the signs correct? Nonsensical results. So the result must make sense in a way. Okay. R2s, negative errors, standard errors. Everything is within the range of model fit. Okay. And then we have goodness of fit. Yeah. So the all these must be must fall into the range. The NFI, IFI, RMCA. The result that you have must fall between the range for the model to have a goodness of fit. Then re-specification, you have to look back. So from what you acquired, the model that you have acquired, so you need to relate back to the theory. So in terms of dimensionality, correct pattern, errors, and maybe other parts that we haven't looked into. Okay? And modification indices and residual has to be shown in the model. What sample size is enough for SAM? Well, it's pretty hard to say, but the more the merrier. Okay, so we must try to get as much as possible. Okay, because some of the model fit, okay, the fit indexes are sensitive to small samples. Okay, so yeah, good model. Okay, so these are some of the I've mentioned some of them. Okay, CFI, RMS, CA, TLI, GFI, all this must be calculated and the result must fall within the range of a good model. So if it doesn't, maybe you have to need to tweak your model, okay, so that we can have a good fit. How many indicators depends? Depends on the theory. Okay, so it's very difficult to say. Okay, or based on your analysis. Uh, Prior concerns, okay, development standards, subject burden. Okay, more is often not better. So you try to include indicators that are relevant. So not try to put everything in one basket. Okay. So this is a software called Amos. Okay, that we use so that we can run the model fit for our model here. Okay, so the data is being keyed in a typical SPSS. Then this Amos can tap into the data from the SPSS to produce to calculate our model here. Okay. So from the results that we have from the GLI, RMCA and everything, if it falls within the range, then our model is fit. Okay. All right. So that is basically a crash course on factor analysis and strategic modeling. So if you are interested to look deeper into this, there's a lot of resources online that can help you. Um, I myself have a few good literatures that can assist you in further understanding this. It's just that I would advise you to get a basic knowledge on uh, this um, factor analysis and SAM before going for courses or start engaging people who are more experienced in doing factor analysis and SAM. Okay, so get your basic strong first, and then when we go and meet people, their input will make more relevant impact to us. Okay, so that is it for my set of lectures for DNE922. I would like to wish you all uh, a great journey on your PhD. Um, just remember, whatever obstacle that you are going through, many others have gone through before you. And if you are patient and you really give it your all, there's no reason why you can't complete uh, that journey lah. Okay. So with that, thank you very much for tuning in. Assalamualaikum warahmatullahi wabarakatuh.